Hello, today we're going to talk about direct variation. So, direct variation is a synonym for direct proportion or proportionality. This means that if you have two variables, let's say x and y, multiplying one variable by a number causes the other variable to be multiplied in the same way or by the same number. The symbol for direct variation is the alpha symbol, and we normally say if y varies directly as x, then the resulting equation will be y is equal to k times x, where k is called the constant of proportionality. When the equation y is equal to k times x is graphed, the resulting graph is going to be a straight line with a gradient denoted as k, and it's going to pass through the origin or through 0, 0. So let's look at some examples. So example number 1. It states that the table below shows that the relationship between the cost of buying turkey lunch meat from the deli. We have our pounds and we have our cost. So we can tell that 1 pound is equal to $1.50. So we want to complete the table based on what we know about the cost per pound. So if 1 pound of turkey costs $1.50, then I would know that 2 pounds of turkey will cost me $3. I know that 3 pounds of turkey will cost me $4.50. And then I know that 4 pounds of turkey will cost me $6. So that is the way that we would complete that table, knowing that for every pound that you increase in turkey, you're going to increase your cost by $1.50. So now we need to use a graph to show that the weight of the lunch meat is directly proportional to the cost. So in order to do that, we need to graph our information. In order to graph it, the most important thing with graphing is that you need to make sure that you label and scale your axis. So when I label my axis here, I have a y-axis, and instead of calling it y, I'm going to denote it as c for cost. And then you have an x-axis, which is going to be denoted as p, which is your pounds. So now what I'm going to do is I'm going to label it. So I'm just going to scale by 1. So I'm going to label my p or my p values or my x values as 1, 2, 3, 4, 5, 6, 7, and 8. And then I'm going to label my c axis or my y axis by 1.5s. All right. So when we do that, we will end up getting the following axis here. So now I should be able to graph. So we already know that 1 pound of turkey meat was $1.50, so we can plot that point there. We know that 2 pounds cost $3. We know that 3 pounds cost $4.50. And we know that 4 pounds cost $6. And we can continue that pattern indefinitely if we wanted to. So what we are going to do here is we're going to draw a line, a straight line through these points. And remember, it should pass through the origin. And it makes sense that it should go through the origin because if I don't buy any pounds of turkey, I shouldn't pay any money. All right? So remember, direct variation, you have to have a constant of proportionality or a slope, and you also have to pass through the origin. So that is how I can tell that that is direct variation. So for part C, it says that we want to find the formula connecting C and P. So we already know anytime we write an equation, it's in the form of y equals. So we have C equals because C is in place of y. And then we have to put our slope, and we already know our y-intercept is obviously 0 because it passes through the origin. So we can say that C is equal to 1.5 times P, or $1.50 per pound. So example number 2, it says, suppose that D is directly proportional to M. if I know that D is directly proportional to M, I know that my resulting equation is going to be D is equal to K times M. So it tells me that when M is equal to 3 and D is equal to 16, they want us to find M when D is equal to 85. Well, the first thing that I need to understand here is I may know what M and D is, but the important part of this problem is that I need to know what K is. What is the constant of proportionality? What am I multiplying by each time? So I'm going to use that information. So where it says when M is equal to 3 and D is equal to 16, I will end up getting the resulting equation. I will end up getting that 16 is equal to K times 3. And I would know that that equation will be end up being 16 is equal to 3K. And I would divide both sides by 3, which means that K is equal to 16 over 3. So that is my constant of proportionality. So now from here, I know that my equation will end up being in the form of D is equal to 16 thirds times M. So now I can answer the last part of my problem because it says find M when D is equal to 85. That is what my question is. So now if I know D is 85, I can say 85 is equal to 16 thirds times M. So now that I have that, I'm going to divide by 16 thirds. So I can put it in my calculator that 85 divided by 16 thirds will be equal to 255 over 16. And if you wanted to put it as a decimal, you could. You could have easily put 85 divided by and put 16 thirds in parentheses, and you would have gotten 15.9375. So either one would be acceptable for your answer. So I would say here that I would have 255 over 16 is equal to M, or you could say 15.9375 is equal to M. And normally when we write decimals, we write it in terms of 3 significant figures. However, because that number truncates or cuts itself off in a nice manner, I'm going to leave it as is and leave it in its raw state. So either or would have been your answer here. All right, so now let's look at what we have when we have powers in direct variation. So anytime you have powers in direct variation, you have to understand that you're now dealing with exponents. Okay, so anytime you are dealing with exponents, you may have an example where it says that y varies directly as x squared. So that means that y varies directly with the square of whatever x is. The equation that will model this would end up being y is equal to k times x squared. So that will be the equation that we're dealing with. So let's look at our two examples here. So example 1 says, suppose that y is equal to 3 times x to the power 4 divided by 5. And then it says state two variables which are directly proportional and determine the constant of proportionality. So if we wanted to rewrite this equation, we could rewrite this as y is equal to 3/5 times x to the 4th, because we already know that x to the 4th has a denominator of a 1, and when you multiply fractions, you do numerator times numerator and denominator times denominator. So the two variables that are directly proportional are going to be y and x to the 4th. Those are going to be the two variables that are directly proportional. So now when you start thinking about the constant of proportionality, or K, and I'm going to rewrite this as Y varies directly as X to the fourth here. That's going to be the two variables that are directly proportional. When I write with K, I'm going to say that this is the same thing as saying Y is equal to K times X to the power of 4. And I know that K is the number that is being multiplied by. So here I already know that my K is equal to 3/5. So those are my two answers. For example number 2, it says, suppose that G is directly proportional to V cubed. It says when G is equal to 15, when V is equal to 6. So for part A, they want us to find G when V is equal to 18. Well, when it says here that G is directly proportional to V cubed, what that is saying is that G varies directly with V cubed, which means that we're going to have the equation G is equal to K times V cubed. So when we have that equation, we can use it to solve multiple things. So I'm going to use that equation that G is equal to K times V cubed. And in this case for part A, we already know that V is equal to 18. So that's going to be K times 18 cubed. So if I do, or if I do that, I would end up needing to see, or end up needing to know what K is. I cannot find K without knowing G. All right. So that's where we're going to use the original information to substitute in. So we can't directly go into using that equation. So what I'm going to do here is I'm going to put in, I'm going to say, okay, well, G, it says when G is 15, V is equal to 6. So I'm going to have 15 is equal to K times 6 cubed. So we already know that 6 to the third power is 216. So I know that I would have to divide both sides by 216. And I know that 15 divided by 216 as a simplified fraction will end up giving me 5 over 72. So that will be equal to K. So since that is my constant of proportionality, I can actually write my equation. My equation should actually be G is equal to 5 over 72 times V cubed. So now that I have my K value, I can now use the equation like I wanted to find or approximate other values. So now when it says that V is going to be equal to 18, I can just substitute in now. So I'm going to have G is equal to 5 over 72 times 18 to the third power. So literally, I just put that in the calculator, and I will end up getting 405. So that means that G will be equal to 405 whenever V is equal to 18. For part B, they want us to find V when G is equal to 120. Well, we already know that we found what K was. We already know that K was equal to 5 over 72 because it's the same problem. So we're going to start back using G is equal to 5 over 72 times V cubed. So now it says we need to find V when G is equal to 120. So here they're telling us that G is 120. So I'm going to substitute in 120 for G. and then I'm going to solve for V. So the first thing that I want to do is I want to divide both sides by 5 over 72. So if I do 120 divided by 5 over 72, I will end up getting 1,728. And that's going to be equal to V cubed. And we should also know that the opposite of cubing is to take the cubed root of both sides. So taking the cube root in the calculator, you will press math and then go down to option number 4. And then you will type in 1728. And then we know that the cube root of 1728 is 12. So we know that V will be equal to 12 in this case. So if you have any questions on direct variation or powers in direct variation, please let me know, and I will be more than happy to assist you. Have a great day.